You guys were gone on Friday, and you might have questions on the answer key. So is there anything that you guys want to ask on BC review number 1 before we pass it up and let Cameron spot check it?
What, number 1?
BC review number 1.
Katrina's retarded. She can do
FRQ 11 and 12.
Yeah.
Okay, I heard 12 first, and then we'll go back to 11. So this was 2008, number 6. Is that right? Yeah. Some of you guys are like, I am bored, because I am good. On 1 and 2, no questions. Already graded them all.
I'm at 6.
So don't worry. It is 2008, number 6, but it was numbered number 12. So if you are bored, don't worry. I got you. There you go. You can start working on homework tonight. Piece review number 3. Yes, you may. Okay. So the rest of you guys can be going over questions. You can be preparing for questions. Here's BC review number 3, though, if you're totally caught up and graded with no questions. Okay. So here we go. Number 6. If you have questions on this, then you should be listening. If you don't have questions, you can be working, yeah? Okay, here we go. Number 6. Gabby, you asked C and D? Okay. So you guys hopefully understood A and B as far as they give us a function forming the general, well, the first 4 non-zero terms and the general terms of the Taylor series. You wanted to think of 1 over 1 minus term by 2x, Katrina. Okay. So once you have the general series in letter A, letter B then builds on that. It asked when evaluated at 1, so when you plug in 1, will this converge to f of 1, why or why not? It's asking about convergence. It's asking will there be convergence at 1. I mean, I would, to be honest, for my, if you're bored, be working on BC review number 3 quietly. Okay, so letter B, the first thing I would do is, it said when evaluated at 1, I would have plugged in. So if I would have plugged in 1, 1, 1, 1, 1, 1, 1, 1, 1, I would have noticed as you go to evaluate, 2 minus 2 is 0, plus 2 is 2. Minus 2 is 0, plus 2 is 2. Minus 2 is 0. So I would have seen the oscillating nature of the sum. That is, I mean, it's not geometric. We could have gone through and tried to do interval of convergence, etc., with the summation, but you can see just by plugging in it's going to oscillate. So that's enough of a reason to say no. I mean, you could have actually put in the oscillating. They just said when x equals 1, the terms of the series do not converge to 0. They're using the nth term test. So they're saying since the limit doesn't go to 0, since it's 2, then 0, then 2, then 0, then 2, then 0, it's not going to converge.
Okay, because I just said the series is alternating, and when you plug in 1, it turns to
But just reading what you said, then that would be that it should converge to 0. Does that make sense? So it's not that the terms cancel out, because this is an infinite sum, so we can't say that all the terms cancel. But what we can say is that the partial sum is going to alternate, or, yeah, you could say alternate, or oscillate between 2 and 0. So therefore, the partial sums cannot be converging to 0. Does that make sense? Yeah. Okay, then Gabby, letter C. The derivative. Now, they were super nice on this. They didn't have to tell you that it's the derivative, but they told you the function you're working with, the 2x over 1 plus x squared, is the derivative of ln of 1 plus x squared. So when they ask for ln of 1 plus x squared, if you have the derivative in calculus, how do we go back? If you have the derivative, we wrote it out. How do you go back to an original? Because they want this guy. Yeah. So then you would just integrate term by term. So the notation that they put, now guys, be careful, grade yourselves hard. You don't want to write anything illegal. because if you write anything illegal, then they're going to have to check X. Now, for those of you that graded with us the other day, you know what that means. For those of you that did not grade with us the other day, sadly, you did not get this experience. So pause, eyes on me, because I have way too many people on their phones when they should be working on things. It wasn't just you. There were like 4. Okay. Eyes on me. Thank you. What is this going to mean when you see it on your FRQ? You would have had it right if you didn't make it wrong. And it doesn't mean that you made the specific place or the specific answer that you got right. It doesn't mean you made that answer wrong. You just could have put something wrong. Meaning, on this one, on letter C, you could have gotten this right. But if you had shown this notation funny or incorrectly, they would have had to take away the point from getting it right. So even if you knew the antiderivative term, even if you did it correctly, if you wrote this notation kind of funny or kind of awkwardly or illegally, then they would have to take away points. Now, it doesn't mean you had to write it exactly like this. It doesn't even show here in the pointage that you had to write the accumulator function. But one way of showing, going from ln and going back, trying to integrate term by term would have been to take the integral from 0 to x of 2t over 1 plus t squared, which we weren't supposed to do. We were supposed to take the Taylor series equivalent of that and integrate it term by term. And as you integrate term by term, then you would end up there. Technically? Yeah, technically, I don't think you would have had to show this integral at all. But if you did want to show your work, that would have been the best way to do it. Katrina?
If you didn't put the bounds, do you get it?
Did you say equals?
And then I do the dot, dot, dot.
Okay, hold on, pause. So you did ln of 1 plus x squared
No.
equals?
No, I just did
Just the integral?
integral from 2t over 1 plus t squared. But I did x's.
That would have been, okay. Technically, though, that would have given you a plus c. Yeah, but if you didn't. Two of the first 4 terms, you definitely would have had that. The remaining terms, you definitely would have had that. I think they would have given you the check on that. Like, you would have had the 2 checks for 2 very different things. You would have even gotten a check for writing the integral. I'll put it this way. I don't think they would have taken away your points for that. The safest way would be the accumulator function, though. Letter D, what were they asking? Use the answer found in part C. So you found the Taylor series for ln of 1 plus x squared to find a rational. Okay, so Gabby on this one, they just told you, hey, you're using this guy. If you look here, do you see how there's an ln inside this little error? So this is an expression of error. This is going to be, whew, that's been brewing for a couple hours. Actual. Why is it the actual? Because it's the one that fits the pattern of the function. So when you're doing error, and we've written error many different ways, s minus s sub n, you could do like f of x minus p sub n of x. There are different ways of showing the error, but always with error, we have some sort of actual and some sort of approximate. Either approximate minus actual, actual minus approximate. We have some sort of subtraction between the actual, the precise answer, and then what we're using to approximate. We always use the Taylor series to approximate. I should say the Taylor polynomial. We use the Taylor polynomial to approximate, the n plus first term of the alternating series to approximate. And whatever the actual is whatever function we're actually trying to find. So ln of 5/4 needs to match ln of 1 plus x squared. So we could say that that is ln of 1 plus x squared when x equals 1/4, because I need 1 plus something to be 5/4. So I take away 4/4 and have 1/4 left, square root it. So I take equal to 12 for x, and I get 1/4. Does that kind of make sense? So I could rewrite this if it helps, that you're trying to, was this alternating? Yes. So I don't even have to think Lagrange. I can just think alternating series. But I could make this f of 1/4 minus p sub n of 1/4 is less than a sub n plus 1. Alternating series less than or equal to? We looked this up the other day. Yeah, right? So then what we're trying to figure out, Gabby, is basically what n for the Taylor series approximation, what nth degree Taylor polynomial will approximate such that the n plus first term is less than 1/100. Does that make sense? So then thinking about the n plus first term, if we come down here and look at we're looking at C, right? Okay. We're plugging in 1/4. So for instance, if I was to plug in 1/4 to the squared term, which would be kind of silly because that would be the first, and so this would be the 0th. But anyway, if I plugged into the squared, 1/4 squared is going to be 1/16. That's not less than 1/100th. Okay? If I was to go ahead and subtract 1/2 times 1/4 to the 4th, that'd be 4 to the 4th is 128, right? And 128 times 2 will be 256.
No, it's 64 times 2.
Oh.
So it's 128.
4 to the 4th?
4 to the 4th. Oh, no, 16 times 16 is...
Yeah, right. This is no. 16 times 16, that would be 256, right? 256 times 2 would be 5/12? Or 512? So then at this point, we have to be like, stink-a-dink for common denominators if you wanted to actually figure out what was, because 1/512 is less than 1/100, but how those two join together. So you could do 2, 3, 32. I did long division, sorry. 16 goes into 51 3 times, 48. 32, that's 2 times the 32. So then I can get 31/512. Now, how do we know if this is less than 1/100th, guys? Just think math real quick. 31/512. How can we compare those numbers? If worst comes to worst, couldn't you? Yeah, this is a non-calculated problem, right? Couldn't you do 31.000? And then we already know that 1/100th, isn't that 0.01? Okay, so if I plug in, that'd be 0, because it doesn't go into 300. But then as it goes here, 6, right? Because 2 carry the 1, 7, and then 30. Uh-oh. But I bet one more, because we're close now, right? So then if I go one more, my next term would have been plus 1/3 x to the 6th. Where were we at? 256 was to the 4th. So 256 times 16, or 256 times 4 times 4. 1,024 times 4? Good. Is that right?
Yeah. That's what I got.
Okay. So 4,096, that'd be 1/4,096 times 3. So now I have my 1/12,288. Now, the sad thing is we'd have to get common denominators of the whole shabam if you really wanted to compare. Not that it's impossible, but you could. So if we divide it by 512, it should go in evenly. If I figured it out how. 4? No. 2? And then 4, 24. So I could do, this guy would be 24/24. This guy is 16 into That'd be 9, 8, no, 7. Six. Ooh, doesn't go unevenly? 12, 2, 8, 8. 42. Carry the 4, 11, 10, 6. Oh, 6 and 6 is 36, believe me. There we go, 768. So then we could go ahead and do 768 minus 2, 24 times 1, minus 24, plus 1. Should end up giving it's 744 plus 1, 745, all over 12,288. This is all, you just want that extra, like, hey, I'm for sure right. Because to be honest, I got that 0.06, I would have guessed one more term and just gone with it to save on time. And if I had time, come back and make sure. Probably make sure with work that I would scratch out just in case I made a mistake. But 7445, I think that only goes in one time. 745. That'd be 3, 8, 4. And carry the 8, which would be 6. I think 6. Did I just do it the wrong way? I'm a dork. You divide the top number by the bottom number. 768, it was 745, right? 12,000 can't go into 7,000. 12,000 can go into 74,000. Well, something went funny on our math. I don't even know what it was. Oh, you guys. I was going with what you said. No one caught me? The 1/2. Thanks, Corey. But then you guys were doing powers of 1/4. Killing me. I was doing these huge numbers when it was so much easier because it was just 1/2. Oh, brother. Gabby, all that to say, that's what you would have done if x had been 1/4. But since x is 1/2, it's a lot easier to plug in. So you can go ahead and figure out 1/4, obviously not 0.01. Figure out that 1/32, obviously not 0.01. But when you come to this one, and you end up with 64 and 3, right? 2 and 1, 252. There you go. So Gabby, when you plug into this one, it would be less than 1. It'd be less than 1/100th. It'd be less than 0.01. So what we forgot to do is solve, and I saw it in my head, and for some reason I kept the 1/4 instead of the 1/2. So this one is going to be less than 1/100th. I mean, you can kind of tell because its denominator is bigger. Like there wasn't even any crazy dividing this to do. And that's a good hint, guys. You saw those numbers I was crunching, right? Does the AP usually make you do tons and tons and tons and tons of by hand work to find an answer? No. So something was wrong. So then, Gabby, if that's true, this would be when n equals 3. Technically, it's a 6th degree term if you want to think about it that way. but it's the third term of the actual sequence. So then we could go ahead and say that a minus ln of 5/4, using what they gave us, is going to be less than this expression that we saw, 1/3, 1/2 to the 6, when, remember, this is one more term than what we actually use for the approximates. We would use just these two terms. This is one extra term. And we can say that this one, if I'd had more space, we figured out that that is less than 1/100. There you go. Ay, ay, ay. Well, that was fun. Yeah, you're welcome. Sorry I didn't catch that 1/4 earlier. That would have made things a lot nicer. Number 1's going to pass it up. We're going to give it back to Cameron. That was the last FRQ. Oh, number 11. Okay, pause. It's a graphing calculator problem, true? So you should have gotten this in your polar mode and polar curve with theta min, theta max of 0 to 2 pi. Area in the second quadrant, it would be helpful to visualize in order to be able to see second quadrant bounds. Because the whole point, they told us second quadrant, that's great and all, but what about the bounds? So when we plug into, mode polar, I was there in honors pre-cal, I should have stayed. Okay. 3 theta plus sine of theta. You guys are in radian mode, yeah? Not that you had to be necessarily for visualizing, but okay, am I in radian mode? Yeah. Zoom standard. Pause, window 0 to 2 pi. 2 pi, check. Okay, now you could make your window go down a little bit if you want to be able, or you could just zoom out if that helps go a little bit faster to see exactly what's going on. But as you guys see, it's going from 0 to 90, 90 to 180, 180 to 270. Check it. What are going to be my bounds for the second quadrant? It's 0 to 3. Didn't it just seem to be going positively the whole time? It never backed in on itself? It's going out. So what are my bounds? Quadrant? Pi over 2 to pi. There wasn't anything crazy like in the second quadrant. It was going back into the fourth quadrant or something like that. So we can literally just use the pi over 2 to pi. If you want to, couldn't you, just to be safe, couldn't you have gone to your bounds and been like, oh, I think it's pi over 2 to pi. Okay, let me double check. Pi over 2. You know what I mean? You could have always double checked that. And so when you graphed it, does that truly give you second quadrant? And the answer is yes. So then couldn't you technically go ahead and, here's a nifty trick, because it's a calculator problem, right? Couldn't you go ahead and do your 0.5 times the integral? You guys know there's a shortcut button, right? I like him a little better. You can do your alpha. Is it window or zoom?
Window.
Okay. Alpha window, you can do your little function integrate. You can go from pi over 2 to pi. How do I steal that polar equation?
Alpha y equals trace.
Yeah, you can do alpha trace because now that you're in polar mode, these are r's instead of y's, just in case you didn't realize that. But remember, it's 1/2 that squared, right?
Yeah.
Then you have to use your variable button, but the nice thing is it's polar, so it's a theta just like you want it to be. Dun, 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 dun. Got it. Okay, sorry, what other parts besides A? Okay. B and then corridors to C. So B, there is one point P with the x coordinate. Wait, x, polar, x equals r cosine theta. Okay, sorry, coming back. With the x coordinate being -3, find the angle theta that corresponds to point P, find the y coordinate of point P, and find the work that, or show the work that leads to your answers. X equals r cosine theta. R, who's that guy? Plug it in, plug it in. You could graph, well, no, you can't actually. I mean, you could graph those two things in polar, but the problem is, guys, in polar mode, is there any such intersect feature? So what would you have to do? Change it to function mode, still be in radians, graph your -3 and your 3 theta plus sine theta times cosine theta, or find the intersections, or add the 3 and find the zeros. But either way, you'd have to be in function mode to do that. Does that make sense? And then last but not least, letter C. Letter C, a particle is traveling along the polar curve, so that position is, oh, hey, it's bringing in vectors and parametric. So it tells us x of t, y of t, tells us d theta dt. D theta dt, it's like they took something in terms of theta. It's like they took something in terms of theta and did d dt to both sides. Why else would you need that? Now, hold on, wait a minute, but we also need dy dt. So hold on, who's y? So I could take the y that I had to do up here, the r sine of theta. This would have been an example if you had done this wrong and you would use that same expression. They could have given you points in this part. Anyway, so you have an expression for y. You have r, you have sine of theta. You need to take that y and take d dt of the whole shebang. When you take d dt of the whole shebang, don't forget your chain rule. So dy dt is equal to, wait a minute. We have our calculator, right? So if we have our calculator, could you have done this by hand? Yes. Did you have to? No. Can I take the derivative of this with respect to a theta? Yes, but the problem is chain rule. I wouldn't have stopped there. What else would I have needed besides the derivative of this guy? D theta dt. So then we could have come up, we could have stolen the d theta dt, and we would have gone ahead and multiplied what the calculator would have given us by what they set up above was 2. And so what the calculator would have given us times 2, and that's our final answer. Corey, does that make sense? Okay. BC review number 1s, pass them up. BC review number 2s, let me pull them up. Let me get these BC review. Please keep them in rows, because that way after Cameron grades them, I can pass them straight back. We're going to go over questions to number 2. Okay, BC review number 1s. Number 1. Number 1? Oh, green name. Does anybody still have the stapler? Oh, you passed it up, Kelly. Get you now. Oh, thanks. Here you go, Amy. Yeah. Thanks, kiddo. Here, I'll steal that. Okay, Cameron. If there's no grading, take off 2 points. Otherwise, half point for everything they don't do.
And is that a
10.
Okay.
Thanks, buddy. All right, what do you guys got? BC review number 2.
Number. Well, I have multiple questions.
That's okay.
Oh, 3.
Number 3?
Yeah.
Huh, I don't know what my zoomy thing is. Hold on. Okay, BC review number 2, number 3. Let me just download it. It's being weird again. I don't know why. Guys, real quick, I think I said it yesterday, but I didn't show it to you. An additional optional practice exam. I am hoping to get back your actual exams to you by Friday, so you can start working on corrections over the weekend into next week. One more required practice exam, but there are optional ones up here, but we are getting staggered review in the sense of just kind of mix things on these reviews, so that's helpful also. But if anyone's wanting an optional for bonus to be working on, they are online. Okay, coming back. BC review number 2, we do have someone with a question on number 3. Let me open up the PDF because that thing's not very happy. And if anybody else comes up with a question after we're done, we'll go over it. So number 3, implicit, yeah? And the whole point is don't make a mistake. So we have 2y dy dx plus chain rule. Bring down the 3, make it a 2 times derivative of the inside, which you need, that's just 0, a product rule. So second d first plus first d second, and then equals 0. At which point, since they say to go ahead and plug in 2, -1, I only have a couple options. Number 1 is try to get dy dx by itself first. Or you can do what I did, which was, why don't you just plug in right now and then move all the numbers away from dy dx. So I went ahead and plugged in the numbers first, did a little simplifying, getting my dy dx's together, and then just solved.
Okay.
Both ways are valid. Any other questions on multiple choice, number 2? Yeah, number 5. Okay, number 5, you're trying to find the second derivative, which means you have to do the first derivative first, which is just chain rule. But once we go to take the second derivative, it's product rule. So if it helps, bring in those shapes. Clearly delineate what's going on. So you can do your second d first. There's your second d first. The derivative first would be chain rule again, derivative of the outside, f double prime. Keep the inside, times derivative of the inside. And then plus first d second, g double prime. Then it was making it match. Yeah. Okay. Value of y. Value of y given dy dx. 2 options. Option number 1 could be taking the indefinite integral, because you can multiply the dx, integrate both sides. You can make u cosine of x. You could do the indefinite integral. You'd have a plus c, but you have a clue that you could plug in for c. Then you would have the entire y equals function, and you could plug in 0. The second way, which would be especially helpful if this was a calculator problem. Sadly, it's not. But the second way, which would be especially helpful if it was a calculator problem, is we could know y of 0 using y of pi over 2, integration is net change, plus the integral from pi over 2 to 0. Sorry. Y of 0 equals y of pi over 2. Yeah, plus the integral from pi over 2 to 0 of my dy dx, or of technically my dy. And then, like, if this was a calculator problem, I could just plug that into my calculator. I wouldn't have even had to switch them and put a negative. So I switched the bounds and made them a negative because I was solving by hand and I didn't like the orientation the way it was. So I switched it and made them negative. But you could have just, if this is a calculator problem, you could have just plugged in 0 plus the integral and been done to get negative 1/3. But by hand, I mean, did you have to do integration? Does that change? No. You could have just integrated, solved for c, and plugged in 0. But then it's just u sub. U is cosine, du is equal to negative sign. So in the substitution, I have a negative, and I have another negative from the negative sign, so the negative negative cancels, and then I go ahead and power rule it and plug in. What's going on next door? Mm-hmm. Number 9 is super, super concept-y. Right? So think any linear function, you can come up with something if you want. 2x minus 1, 3x plus 4, any mx plus b. Take a derivative of any mx plus b. Yeah, that's what I did. And the derivative of mx plus b is just m. Derivative of m is just 0. So then this just ends up being 0. Integral of 0 is going to be the constant. And then 0. Yeah. Number 10. Someone asked about this one yesterday, right? I forget who it was. Oh, just to see the answer. This is a graph of a derivative, barrels per hour, so it's a rate of Oh, you're measuring the oil in barrels. That's kind of awkward, but okay. So how many barrels of hour, or how many barrels per hour are being flowed through this pipeline, or flowing through this pipeline? So this is rate, and they're asking for the total number of barrels of oil that passed. I mean, we could think total distance and then absolute value, but all of this area is positive anyway. Why am I talking about area? Because this is barrels per hour. To get to barrels, I need to integrate. So that says to approximate. We have a picture, so we can approximate using area. So I did 6 times 100 is 600. And so at first I was like, okay, full 600, 1, 2. Then I was like, 3, 4, but a little bit less. And then I go putting these two together. If you try to visualize them, it's a little bit messy. But you could almost do 1, 2, 3, 4, 5-ish. And that's how I got the 3,000. Corey. Number 9 should have been A. Linear mx plus b, derivative m, second derivative 0. Integral of 0 is just c, and c minus c is 0. Anything else? Any answers we want to see, or any FRQ questions? Yeah, go ahead. 11A? Okay. Sounds like water or something. What's going on? 11A, and then you said B, Katrina? And D. Okay. You guys get the basic scenario, right? We have a guy diving, but it can't be like AB because he's moving horizontally and vertically. He's moving out and up and down. So then we have his rates, horizontal rate of movement and then vertical rate of movement. They gave sort of initial, right? His shoulders are 11.4 meters above the water when she makes the leap. So that's 11.4. The horizontal distance from the front is x. The vertical distance from the water's surface to her shoulders. So this can be my y of 0. And then A is the time that the shoulders enter the water. Okay, so find the maximum vertical distance. Well, maximum vertical distance, I want to find the max y, right? To find the maximum of y, can't I do critical numbers and endpoints? So I'm going to go ahead and look at y prime, or dy dt, set that equal to 0. And we know just from the picture, but I mean, we'll be able to find with the math too, that if she starts here and goes up and goes there, I'm trying to find when the vertical rate is 0. Guys who are talking, this time is a gift. You're distracting. Quiet it down a little bit. So when we go ahead and subtract negative 3.6, divide by negative 3.8, what did you guys get as your critical number? T is equal to?
18 over 49.
This was back in the olden days when the calculator was permitted, so you could have just done a decimal, or you could have solved it either way with a fraction. But then, Alan, they don't even say justify. So to be honest, all they wanted you to do was find the 0 of y prime. For letter B, it says find A the time the diver's shoulders enter the water. Yeah.
Because for that one, I was just confused because I did integration is that change. And I didn't know why it was like
Yeah, on the answer sheet, they did integration.
For the maximum vertical distance?
Yeah, that's why. And I don't like integration is not the change.
Ooh. Here's a struggle. Are they asking for the time or for the actual distance? So you have to plug it in. So you want to know how high she is. So you need to know how high she leapt. Shoulder. You need to know the 11.4 plus the change in height from there to there.
Okay.
So to find y of, we can call that b, because we have a being something else, y of b. We're going to, because it wants to know what is her height here. Not how far she's gone, but what is her entire height off the water. And then for letter B, when it says the time the diver's shoulders enter the water, I mean, looking at the how y is defined, it's how far shoulders to the water, right? So when it hits the water, don't I know y of t is equal to 0? And I already have a function for y of t?
Yeah, you found it in A. Oh, so you said
You could have found it in A. Oh, you had to plug in anyway. So yeah, in some way, shape, or form, you had to think about y of t. I don't think you actually defined it, though, in A, did you? You could have just integrated with your calculator and added. Anyway, you want to find a function for y of t by integrating. So you could just multiply dt to the other side and then integrate. And once you integrate, you can use your clue, your at 0. The height of her shoulders off or from the water is 11.4. And then after you find the plus c with the clue, you can set equal to 0 and solve. Is that okay? And then letter D. Ugh. Find the angle between the path of the diver and the water at the instant the diver's shoulders enter the water. Don't we have expressions for y and x? And couldn't we talk about when the diver enters the water? I mean, if you guys want, you can be like, okay, let's pretend she's not straight up and down. She's entering the water, right? There she goes. And as she goes, I guess this would be her shoulders right here. As she goes, y is how far off the water. X is how far over. But the struggle is, at the instant she hits the water, how are we supposed to figure that one out? Because at the instant she hits the water, isn't y equal to 0? So how do we find a delta y and a delta x if we have her at 0 and... Ooh. Can we think tangent line? And once we think tangent line, maybe we can think tangent inverse? Yeah, we're really just trying to find the slope, right? Because if we can find the slope at the instant she hits the water, oh, that's dy dx, then we can go ahead and say the slope linearly could be used to find the angle using tangent. So then let's go peek at wherever it is. Is this the diver one? Yeah. Yes. There we go. So you can find dy dx using y prime over x prime. We find that angle, and that change in y over change in x of the tangent line is going to be an opposite over an adjacent, and an opposite over adjacent can be used to find the angle of inclination, you could say, by just using tangent inverse. Now, crazily enough, for any of you that had pre-cal with me, we learned this formula in Chapter 10, Section 1, beginning of conic sections, that slope is equal to tangent of theta for any inclination of a line. Which could be helpful, because that's just derivative, and then... But if you think slope of a tangent line, well, a line, slope, sweet, tangent inverse can get me theta. That was tricky. Okay. Anything else on FRQs or multiple choice on BC review number 2? Alan? 12?
Yeah.
Is that... how do you get to 0 from -1 in 2 equal steps? 0.5s. So you can go from -1 to -0.5 and -0.5 to 0. Remember with Euler's method, we used a little approximation. We used the y value from before, which would have been the 2, plus we use the differential equation they give us, plugging in the point times the step size, which would be 1/2. So then you just have to plug and chug to get there. For letter B, they tell us the value of the second derivative and talk about a Taylor polynomial. We better think of the definition of a Taylor series and plug in. So we can use our f of -1 plus f prime of -1 all over, I guess, 1 factorial times x plus 1 plus f double prime. And how am I going to find all these guys? They gave me the clues. I can plug into the derivative for f prime, and I can use the second derivative for f double prime. Does that make sense? So we're using the differential equation and then what they gave us as the clues to plug into our definition of a Taylor series. Well, Taylor polynomial stops at the second degree. And then letter C, find a particular solution to the differential equation. It was good old-fashioned multiply dx, separation of variables, get everything oriented, integrate, solve for C with the clue, get y by itself. So then if there's a place that made a mistake or you can't figure out how to get from one jump, let me know. Kiddos, we basically got through the questions to BC review number 2, which means you should be ready at the very beginning of tomorrow to hand it in for a spot check. Does that sound good? BC review number 3, have it ready for questions because we'll get into it pretty much right away, unless someone has a quick remaining question from 2. Sound good? All right. Cameron can grade it real quick at the beginning of tomorrow. So that's less paper for me to deal with. Oh, there you go. Oh, got it.
So just leave it on the desk. Or where you're in.
Yeah.